All right, Math 1 people, this is lesson 3.3, Solve by Elimination. In Khan Academy under Math 1, we're working through the unit titled Systems of Equations, and this lesson covers skills 7 through 9 in that unit. Let's go ahead and get started. We have learned how to solve linear systems by graphing, that was in lesson 3.1, and substitution in lesson 3.2. Now, we will learn how to solve the linear systems by using a method called elimination. So go ahead and fill in that blank. And then once you've written the word elimination, I want you to do something a little bit different. Let's set down our pencils because the method of elimination is a really useful tool. It's based on this really neat trick, but I feel like I would be doing you a disservice if I just showed you how to do the trick without explaining the math behind it. So you don't have to write this part down. I just want you to listen, and please ask questions at the end of the video or in class next time I see you if something doesn't make sense, okay? So the method of elimination is really based off of this idea. So let's say we know A is equal to B, and we also know that C is equal to D. Okay, so we have two equations, and you know from learning about substitution, when we have an equation like this, it means anywhere we see an A, we can replace it with B. We can substitute. Similarly, anywhere we see a C, we can replace it with D, okay? Now, this is where the trick for elimination comes from. We're going to think of a new expression, A plus C, and really it's just the sum of the left side of those equal signs, right? So that new expression could be rewritten. Since A is equal to B, we can substitute A for B, or rather substitute B for A. And then again, since we have a C here, we can replace it with D. All right, so I'm going to clean this up a little bit. So this is true, and if you understand this idea, then you understand the math behind the elimination method. Let me show you what I mean. Let's say we have two equations, right? And then we're going to come up with an expression. Let's call it 3x minus 4y plus 5x plus 4y. Well, I know that all the red stuff in parentheses there, it's equivalent to 10, so I'm going to substitute it. And then, same thing, all this blue stuff is equivalent to 6, so I can just replace it with 6. This equation must be true if these two are true. And then from there, what makes the elimination method work is the fact that when we combine our like terms, those y terms are opposites. They're going to cancel out, and we'll be left with, we'll combine our like terms, we'll get 8x, and then these cancel. 8x equals 16, and then we can solve for x. Again, we're going to write this down in a different way in your notes. So let's go back to your notes. You can pick up your pencil, and these are our steps for solving using elimination. Step 1, we want to make sure that all of the variables and the equal sign are lined up. And they put that in quotation marks because really what we're talking about is both of the equations need to be in standard form. Remember, our standard form looks like this: ax plus by equals c form, right? So then we might have another equation. That'd be our first equation. Maybe we have another equation that's dx plus ey equals f. And because the x terms are lined up, the x terms are lined up, the y terms are lined up, the equal signs lined up, the constants on the other side are lined up, that's what we're trying to get in step 1, okay? And then step 2, we have to decide which coefficients we want to cancel out. To cancel out, they must be opposites, kind of like we saw in the example. You might have to multiply, that should be multiply, not multiple, the equations first. And write this part down, please. Think LCM, that stands for least common multiple, okay? So the least common multiple of 4 and 4, well, that's just 4, right? You want to make one of them negative and one of them positive, but they're already their least common multiples, okay? And then we're going to add them. So I'll talk more about step 2 and step 1 in the next example. But let's go ahead, and since step 1 for this example is done, they're lined up. Step 2 is done because they're already opposite. The y terms are already opposites. We can move on to step 3. We're going to add the two equations, and really, we're just adding the left side of the equations and adding the right side of the equations like we did in my explanation. We're just writing it in a different form, okay? So if we add them, we'll get 8x. The y terms will cancel. It's really just 0. You don't have to write it. I will this time, but most of the time I don't. And then 10 plus 6 is 16. So really we have 8x equals 16. And if we divide both sides by 8, we'll be left with x equals 2. Okay, now that was step 3 here. I'll write it in a different color, I guess. We just finished step 3. Next, step 4 says to take your answer to step 3 and substitute it into one of your original equations. So I'm going to take, I'm going to choose the bottom equation because I like to work with these positive coefficients instead of a negative one. But you could use the first equation just as easily, okay? So let's take the first equation, 5x plus 4y equals 6. And we're going to take this value for x and plug it in. And then we solve for y. So 5 times 2 is 10, plus 4y equals 6. We can subtract 10 from both sides, and we'll get 4y equals negative 4. If we divide both sides by 4, we're left with y equals negative 1. That was the end for step 4. And step 5 is our last step. Just like with graphing and with substitution, we want to write our final answer as an ordered pair. So step 5, we'll say that x comma y, our solution is 2 comma negative 1. That's our answer. Okay. So I've got 4 examples for you. Let's try example 2 together. There, let's use red. Step 1, are they lined up? Well, the x terms are lined up, the y terms are lined up, the equal sign's lined up. Yep, they're lined up. In other words, both equations are in standard form. So we can check that box. Step 2, do we have opposites? Either are the x terms opposites or are the y terms opposites? And in this case, the x terms are already opposites, right? 2 and negative 2. So we can move on to step 3 here and add both equations, right? So we get 0, negative y minus 3y is negative 4y. 12 plus negative 12, that's 0. All right, so we can solve for y. Let's divide both sides by negative 4. That's allowed. Remember, we can take 0 and divide it by a non-zero number. You just can't go the other way. You can't take a number and divide it by 0. So this is allowed. Y is 0. Step 4, we're going to take this value of 0 and plug it into one of the 2 original equations. I chose to use the first equation. And so I plug 0 in for y, that was right here. And then we solve that equation by dividing both sides by 2. We'll get x is 6. Step 5, we write our answer as an ordered pair. Okay. So this is usually the point where I would tell you to try number 3 on your own and then come back and check your work. However, all the examples you've seen so far have had opposites already. Now, in example 3, we're still already lined up, so that's good. We can check off step 1. But step 2, we don't have opposites. This is a 1x, and that's not the opposite of negative 6x. And 2y is not the opposite of itself. We really want one of these to be negative, because then we'd have 2y and negative 2y. So I want you to do that part with me. Let's multiply both sides of the second equation by negative 1. And when you do that, it just changes the sign. This negative 6 becomes positive 6, and this plus 2 becomes minus 2, and this negative 10 becomes positive 10. All right, so I want you to do the rest of this problem on your own. You have this system of equations here in green, and I want you to do steps 3, 4, and 5, and then come back and check your work. Okay? So when we add our equations, we get x equals 2, not negative 2. So that's step 3. Step 4, we're going to take this 2 and plug it in. I chose to plug it into the first equation. You could have used the second equation if you wanted. And then I solve that for y, and I get y is 1. Step 5, write it as an ordered pair, and then we're done. Okay, now let's look at example number 4. The equations are both in standard form, so step 1 is done. Step 2, do we have opposites? No, we don't. So we have some choices. Remember earlier I told you to think about the least common multiple? That's what I mean. What I mean by that is if we look at the x coefficients, 4 and 2, the least common multiple of 4 and 2 is 4, right? We could have tried the y's. The least common multiple of 3 and 2 is 6, but this will be the quicker way because 4 already shows up as one of our answers. So what we can do is multiply both sides of the second equation by negative 2. And then when we distribute, we get that opposite. See how 4 and negative 4 are opposites now? That's why I chose negative 2 and not just 2. And then we can go from there. Now, if you really wanted to, you could have multiplied both equations to get the least common multiple of the y coefficients. I guess you could have done maybe 2. And then when you distribute, that'll be negative 6y. So we would need to multiply the second equation by negative 3 to get positive 6y. But that's more work for you. So let's just do it the way we did. There we go. And when we add, we just get y equals 8. That's already solved for y. So that's step 3. Let's take that value for y and plug it in. I chose to plug it in to the second equation because it's working with smaller numbers. So I plug in 8 for y. 2 times 8, that's 16. So if we add 16 to both sides, we'll get 2x equals 16, which means x is 8. If we write this as an ordered pair, then we're done. All right, so for our last problem, example number 5, let's cancel the x coefficients. You could do it with the y coefficients. I'm just picking x. So we look at the coefficients. They're 9 and 6, and the least common multiple of 9 and 6. Remember, if we count by 9s, 9, 18, 27, 36, and we count by 6s, like 6, 12, 18, and so on, 18 is the least common multiple, right? So I'm going to multiply both sides of both equations so that we end up getting 18x in one equation and negative 18x in the second equation. So I'm going to multiply the top equation, let's say by 2, which means, because 2 times 9 would give us that 18, and since that'll be positive 18, I want to multiply the bottom equation by negative 3. Okay, that way I get negative 18x in the second equation. Make sure you don't forget to distribute. That's how I got 4y instead of 2y like before. And then same thing here, when you distribute, that's how we get this negative 39y, okay? But from there, we can add the equations, as they say, and these will cancel. We'll be left with negative 35y equals 105. And dividing both sides by negative 35 will tell us that y equals negative 3. We plug that back in where y was in either equation. I chose the first equation. So I took this first equation, but replaced y with negative 3. And then if we solve that, we can multiply to get minus 6 here, add 6 to both sides, divide both sides by 9, and we'll be left with x equals 5. We take our 2 halves of our answer and write it as an ordered pair, and then we're done. As always, don't forget to either ask me a question about what you saw in this video, or make up a math problem, make up a question related to this stuff, and then I will see you in class.